The area we mapped on the lunar surface is approximately 400 miles by 250 miles in size. And in that small area on the lunar surface, we have approximately 12 kilometers of elevation difference. And to put that in perspective, on the entire land surface of the Earth, from sea level to the top of Mount Everest, we have about 9 kilometers of height variation. So you can see that the south polar area of the moon is an extremely bumpy and varied terrain. We mapped the South Pole for a couple of reasons. First, we wanted to assist NASA in providing information about the possible landing sites on the South Pole of the moon. So in particular, we wanted to make elevation maps to help them out. We beam radio waves from these large antennas toward the moon, and it takes about 1.25 seconds for them to reach the surface of the moon. And then they interact with the structures on the moon, the mountains and the craters, and even the small-scale rocks. And a portion of that energy reflects back toward the Earth. And we record that energy at another large antenna in the Mojave Desert on a computer, and then we process that data after the fact to generate our height maps. Other people have mapped the surface of the moon, but they haven't mapped it to nearly the accuracy we've been able to map it with. And by mapping it at this improved accuracy and this improved resolution, it allowed us to make better slope maps or determine how steep the surface is from point to point on the lunar surface. And that's very important for being able to understand how easy it's going to be to move on the lunar surface. And one of the things that we found is one of the places that we thought we might want to land on the moon turns out to be a little bit steeper than anticipated.
Station Commander discusses life in space with Iowa media. Aboard the International Space Station, Expedition 16 Commander Peggy Whitson and